Teacher.
Misha? Joseph?
Yes, please.
You'll try to manage it from that end. I think I still have a challenge here. I'm not reflected as a co-host yet. So you'll try to mute students.
All right, please. All right, please.
Can we hear from Misha? If Misha is not ready, can I hear from Vanessa Tkunda? Vanessa?
Maybe, see, I request someone to put up a hand. Maybe that will is our.
Okay. Can we get a volunteer to pray?
Yes, we have Faith.
Okay.
Faith, very first. Faith, we are waiting for you.
Let's humble ourselves and we pray. Loving Father, I want to thank you for this day, for all you've done for us. As we are going to have this mathematics lesson, we pray that we will understand everything and that the connection will not be disrupted due to the rain. In Jesus' name I've prayed. Amen.
Amen.
Thank you, Faith. I don't know if my screen is visible. Is my screen visible to everyone?
You're starting to share.
I'm starting.
Yeah.
I guess my network is unstable this afternoon, but let's pray that we'll go through it easily. Girls, I know some of us have already turned in our exercise, and there are those who are still struggling. We don't know how to use Google Classroom. There are some who haven't joined, which is unfortunate. These are 2 weeks, 3 weeks. So by this time, I expect everyone to know how to navigate the platforms and how to answer whatever assignments that the teachers keep posting on the platforms. So I saw your marks. Some people are still having a challenge, I guess, with this work. And last week I said we are going to attend to any questions that maybe could have accrued along the way as we are doing this topic, because today we are winding up the topic. When we meet again, we are going to look at I think topic 7. So I guess I can get some questions from the students as far as this work is concerned. Is there something which you feel the teachers should give more highlight on before we can? This is a question and answer session to help you understand what you didn't understand.
Okay, we have Shaggy, maybe first.
Yes.
Rukia, please go. Shaggy. Rukia, please go on. We are waiting for you.
Teacher, I didn't understand number 5 about the double machines.
Number 5 about the double machines.
Yes.
That's on
page 83.
Okay, page 83. They said draw down machines that could be used to get each of these sequences from then write down a formula for each sequence. Joseph, is my screen visible?
No, please.
Hey, sorry. Joseph, maybe you try and share on your end, or let me share again for the last time. If it fails, then you can share from your end.
Okay.
Yeah. So wanted draw a machine. I guess they don't expect two machines. Someone was asking.
Mr. Thea, I think your network isn't good this afternoon because you're failing to share.
Joseph,
Yes, please.
can you share? Share from your end.
Okay. I think Shaggy was asking about a double machine, but to go through that very first, a double machine is not far different from a number machine. Only that for a double machine, you can enter two inputs. Okay. So for your case, you can do a same case or diagram like the one you had for a number machine. They just wanted you to have another phrasing of a number machine, because for it allows entering two inputs. Say if you're having two
I can't hear,
numbers.
you're breaking.
Pardon?
They are saying they can't hear you. Maybe you can.
No, we can't hear you. I can't hear you.
Joseph, can you try to repeat, please?
Okay. I was saying that a double machine is not far different from a number machine. Only that for a double machine, you can have, or you can enter two inputs at once. So for your case, you can use a number machine, the drawing that you know already, and then enter each value independently and test which formula you need for the sequence, which is your output. Hope I'm okay now. Okay, Mr. Theo, you can go on now. You're able to share. We're able to observe your screen.
Okay. I guess my network is not the best this afternoon. So, so someone was asking about the DAO machine that could be used to get each of these sequences from. So Joseph, I don't know if I can. Joseph.
Yes, please. Mr. Theo.
Sekira, can. There's a student who is sharing the screen. Sekira, can Sekira Daniela stop sharing, please? She's hijacking my sharing rights. Sekira, if you do that, I'll chase you from class again. If you do it again, I'll chase you from class, please. Joseph?
Yes, please.
I see you're trying to share screen.
No, not really. I stopped a long time ago.
Yeah.
Okay, maybe you're starting to share.
Yes.
You're starting to share.
Is it visible?
Not yet. I don't know whether Bruno is on.
No, I guess my network is not stable today. But you were trying to help the girls understand this, and could you try to share, please, again, because some people are saying they're not hearing what you're saying.
Okay. So I say that a double machine is not far from a number machine, the one we know already. Only that for a double machine, it can enable you enter 2 digits or 2 inputs at once. But for this case, you can have the same drawing as for a number machine that you know, and you enter each value separately, and then you identify what is the purpose for the machine. When they ask you for the purpose, they want you to find what it does really to obtain the other output or the sequence you have on the other end, or as your part A or B, whether it is adding a given value or subtracting a given value. That's what they want you to identify for a purpose. I hope now I'm okay.
So, Joseph,
Yes, please.
would someone be correct if they draw a similar machine like what we've been seeing in the questions?
Yeah, it's okay.
And they put in the values that they have been given.
Yes.
So does that imply that we are going to relate the values that they have given us with part A, part B, part C, and we get the counting numbers they have given us 1, 2, 3 up to that, and then we try to see which process takes place for you to get the output of A, and
Yes.
which process takes place for you to get the output of B, like that.
Yes.
I want us to demonstrate using the part A. I don't know if my screen is visible.
Yeah, it's visible. Very well.
It's visible. Okay.
Yeah.
So we had 1, 2, 3. We are stopping on what? Can you check for me and you tell me? I'm not seeing on the document. Up to 5?
Okay. Yes, up to 5.
And what is the output?
You have 5 for part A, you have 5, 9, 13, 17, and 21.
17 and 21.
Yeah.
Okay. So, for example, if we put in 1, it's yielding 5. Okay. If we put in this first value of 1, you get the first value of the output. What you're having is the input, or what you put into the machine. And then what you're having this side is the output, or what you get out of the machine. So there is something which takes place within this machine that we're interested in finding out. So when you look at, if you compare 1 and 5, what do you do on 1 for you to get 5? Maybe we just get it from the students.
Yes, please.
Whose hands are up?
Yes, we can have Vivian. Vivian.
Vivian, can we hear you?
Maybe she's not on. We can have
the next person.
Yes, we can have Hope.
In order to get 5, we get 1 plus 4.
We get 1 plus 4. So it implies, by the way, for you to test the consistency, you can try out the second value. Okay. So let us try out the second value, which is 2. When you try out 2, do you get the same? I mean, do you get the same property or the same formula? If you try out 2, if you put 2 into the machine, do you get because you've said you're having 1 plus 4. So if we put 2, how do we get 9? Any idea? Joseph? Do you
Yes,
have any
please.
hands up? I'm seeing 14 hands up. Can you try to get from those students and
Yes,
to
we,
run as
we can have Michelle. Michelle.
What do they mean by the nth term?
Sorry?
What do they mean by the nth term?
What do they mean by the nth term?
Yes.
Okay, when they talk of nth term, they basically mean some term far away from, you know, the values you're working with. It can take on any value, okay? So nth term is like maybe the term you get if you substitute in any value of any. So there is no specific value of nth term apart from knowing that it is any time you get once you've substituted in some value or some number, depending on what the question is asking.
Okay.
Yes, Joseph. Can I hear from the rest?
Yes, we can have Ario. Ario, please say something.
+1.
Yes.
4n plus 1.
4n plus 1. Okay, the first person said you get 1 plus 4, which was giving us 5. So you are saying, are you?
1 plus 1 equals 5. The next one, 4n plus 1, 4 times 2 plus 1 equals 9. 4n plus 1, 4 times 3 plus 1 equals 13, and you continue.
Okay, I think Aria is trying to make sense out of the number that you shall be getting 1, then 4 times the natural numbers given. Is that what you're saying, Ario?
Yes.
We see that we keep adding 1, then plus 4 times the natural numbers given.
16, 17.
You see that 1 plus 4 times 5, which gives us 21. So generally the term you are looking for is 4n, or 4 times n. Okay? Because n is taking on this n here is taking on these values 1, 2, 3, 4, 5. So it in our machine, the formula they want us to get is 1 plus 4n. Okay. I don't know what my other colleagues have to say.
Mr. Theo, someone is asking in the chat. Maybe she wants me to echo what a DAO machine is. Now, I will give you an example. Okay, say for part A. Okay, if you look at that sequence, there is a difference of 4 for each term, whereby you're having from 5 to 9, you're having a 4, and then from 9 to 13, you're having a 4 as well. It is consistent adding on a 4. Now, I say that a DAO machine is similar to a number machine, only that for a DAO machine, it helps you enter 2 digits at once. So for example, if you want to find the difference, you can enter the 2 digits, it subtracts them to find the difference and check whether it is the same for other 2 consecutive terms if you enter them. So for example, if you entered a 5 and 9, the difference would be a 4. But is it consistent if you entered 17 and 13? If it gives you a 4, then it will help you determine the difference between the sequence you want, particularly for part A. I hope I'm okay now. All right, Vicky is okay now. She has gotten it, so maybe Mr. Theo can proceed.
Okay. So the question, they wanted to find the formula for getting this sequence. And from what we are seeing here in part A, we are seeing that what they wanted us to use in the machine was 1 plus 4n, where n
Yes.
is taking on the counting numbers, which are
Yes.
given as 1, 2, 3, 5.
Yes.
Okay, but you can see we arrive at that by looking at the trend, how we are moving. If you look at how we started, get at 5, you had 1 plus 4, but 4 is the same as 4 times 1. So there is that imaginary one there. Then for you to get to 9, you'll have 1 plus 4 times 2. Okay. For you to get to 13, you'll have 1 plus 4 times 3. For you to get to 17, you'll have 1 plus 4 times 4. Meaning that we keep on getting 1 plus 4 times the counting number, of which the counting numbers are represented by n. Okay, that's why I'm saying that generally the formula they are asking us to determine is 1 plus 4n, and that's what you have in the machine.
Yeah,
I don't
very
know
well.
if it makes sense.
Yes.
The hands which are up, we can attend to them before we move on.
Sophia, let's hear from Sophia.
Teacher, what if in the number machine you put +4? Because in the examples on page 81, they just put plus this plus that, but they don't put like 1 plus 4n.
Okay, Sophia, I get your concern. So when you put +4, then Sophia?
Yes, please.
Yeah, when you put +4, do you realize that most likely you will not get the output? It only works for the first term. Now,
Okay.
I think we can make it clear that this demo machine takes on operations, of course, the plus, the minus, I mean the subtraction, the multiplication, and maybe the division. But it does not stop the machine from taking on some kind of a formula. Okay?
Yes.
That's what I think. I don't know if what my other colleagues think about it.
Yes. Okay, Teacher Martha, you can go on.
Good afternoon, teachers. Good afternoon, girls.
Afternoon.
When it comes to this double machine, when you look at the single machine we have on page 82, as Sophia has said, you realize we are only using one operation. We are adding or multiplying, but by one operation. But when it comes to this double machine, you realize all the examples we have will not specifically give us a direct answer, like the examples on page 28, on page 82, sorry. So you notice that this double machine is introducing something else, like we have double operations, like Mr. Theo was illustrating. On the board, you realize that we have 4n, which is 4 times n, which is the first operation, and then +1, which is the second operation. I don't know whether that one brings it out clearly.
Thank you, Martha. Maybe let me see. I'm trying to think of the easiest way of doing it. Let's simplify it this way for the girls. This machine has 2 operations it's doing. The first operation is it's multiplying the difference by the terms, by the natural the counting numbers given. Okay, maybe let's do it this way. This machine here This machine here is doing something of this kind. The first thing it's doing is this. Okay, it's getting that term and then it multiplies by 4. Then the next thing it's doing, it's adding a 1. Okay, so it's doing two tasks. Okay, so I was combining, I was getting a 1 plus 4n, but you can also start with 4n plus 1, doesn't matter. Okay, so I don't know if this maybe tries to simplify it for the girls, that what that machine is doing, it's doing 2 tasks. The first task is getting the difference times the natural, the counting number. And then after that, it adds a 1. So this is the formula I had. Okay. I don't know if it makes sense. I'm seeing hands up. Can you attend to that, Joseph?
Yes, please. We can have maybe Charity. Charity, let's hear your concern.
Excuse me, teacher. I just wanted to ask about the answer for number 9 in the assessment exercise that you sent over the weekend. What was the right answer? Because according to my calculations, the right answer was not given in the options, but people said that the right answer was there. So I was just asking if you could explain more about that number.
Charity, I'm going to ask you to be patient. You are going to check that exercise. Let's first clear this.
Okay.
And check it. There was a time we rectified the data. Okay. So,
yes.
Joseph, I don't know if you have more hands to this question, because I want us to move on to.
Yes, we have, but we can have maybe 2 before we proceed. We can have Patricia first.
Why do we add 1? Why do we add 1?
Patricia?
She's asking, why do we add 1?
She's asking, why do we
add 1?
Oh, why do we add 1? We are adding 1 because we are looking at the output vis-a-vis the input. What you put in relation to what you get out. So we have to basically analyze what we are given, what we are putting in the machine, and what we are getting out, and then you try to see what could be the possible relationship. So there is no standard formula or method for adding. We basically analyze what we have got out of the machine vis-a-vis what we put in the machine. Does it make sense? Joseph?
Yes, please.
More hands?
We can have Eunice. Eunice, please go on.
Teacher, I'm kind of confused on that thing since my internet wasn't working so well on the machine.
We are specifically.
Eunice, what is confusing you?
And you're talking about that part of 4n plus 1, that one.
Okay, Eunice, we said that this machine is doing 2 tasks. Okay, it's doing the task of multiplying the counting number by the difference. You realize that the difference between the output was 4. So we are getting the counting number, which our counting numbers are 1, 2, 3, times the difference. The difference is 4. And then the value we get, we add a 1 for us to arrive at the output. Okay? Now, if you put the first value of n, or the first value of the counting number, which is 1, you'll get 4 times 1, which is 4. But you realize that that's not the output. The output is a 5. So how do we arrive at 5? We have to add a 1. Now, for it to confirm if what you're doing is right, you test the next value, which is a 2. So you'll get 4 times 2, which is 8, but you realize that the outcome was a 9. So that means you have to add a 1 on what you have, which is 8 plus 1. You can as well go ahead and test the third value, which is 3. 3 times 4 is 12. The output you're having is 13. Okay, so we cannot have 12 as the output. Instead, you have to add a 1 on 12 to go to 13, and you keep on doing that. I hope it makes sense.
Yes, but teacher.
Yes.
Teacher, on this exercise which they gave us in the number machines, I tried that method on like these other numbers, but they didn't give us. I tried the same method, but I didn't get the output.
You tried the what?
I tried that method for finding the difference. Then I add 1, but the outputs I got were different.
Yeah, but we shall not always add 1 all the time. We add depending on what the question is saying. Okay. So don't always add 1, because in the class we did an example which had adding a 1. Add depending on what the question is saying, because this question could have been changed. They can, instead of having 5, you can have a 6 here, have a 10 here, maybe you have a 14 here, maybe you have 18 here, maybe you have 22. So do you realize that we are still using the same formula, but the output is different? The output is different. The difference is still 4. Okay, but when you get the counting number times 4, you'll have, for example, the first one, you'll have 1 times 4, which is 4, but the output is 6, meaning that you have to add a 2 for you to reach 6. Then when you go on 2, you'll have 4 times 2, which is 8, but the output is 10. So that means you'll get 8 plus 2. So depending on which output you are having, we add a value depending on what we are given. So not all times you are going to be adding a 1. Okay?
Okay.
Yeah, so always analyze the output vis-a-vis what you are putting in the machine. Don't cram that all the time it's adding 1, okay? Does it make sense?
Yes, it does.
Okay, can we move on, Joseph?
Yes, I think for now you can first move forward. We shall see as time goes on.
Okay. Can we check the next question? Maybe we try out one more number on the DAO machine so that we help them understand.
Okay, we can have maybe part E.
What is part E saying?
You're having a sequence of 102, 202, 302, 402, 502.
Okay. So our input is 1, 2,
2, 3,
4, 5. Eh? This is what you are putting into this machine. Eh?
Yes.
We are getting out here. What is it?
We have 102.
102.
202.
202.
302. 402.
Okay, even if you stopped there,
yeah,
we can able to demonstrate. Okay, maybe we can get from the girls, given what we've just done. I'm seeing hands up. Can you try to see if we can get someone to?
Yes, we can have Primrose to say something.
The formula that I think we can use is 100n plus n. Since the 100n plus n.
100n plus
n.
Plus n.
Yeah.
100n plus n. Like this?
Yeah, like that.
Do you think that will lead us there? Can we test it? Because this is 101n. I hope you know that. That if I get 100n plus n, I have 101n. So do you think that is correct?
That's what I think. I'm not sure.
You're not sure. What do your friends think? I see 17 hands up, Joseph?
Yes, we can have Melissa. Melissa, please say something.
Teacher, I wanted to ask a question related to work we had done the other time. There was a number that I didn't understand.
Melissa, can we finish this and then maybe after this question we can open up for those other questions? We try to, let's do one number at a time, eh?
Yes.
Joseph, can you pick one other person who can contribute to this, what we are doing at the moment?
Daniela, maybe?
Sheffield, I cannot see your screen. I think that's why even I screen shared by mistake.
You cannot see my screen. Are the rest seeing my screen? Can I hear from the rest?
Yeah, to me it is visible. That's what I can say. I don't know.
Let me hear from the girls.
Other girls,
Try to unmute someone.
Esther.
Teacher, I think that answer is 100 plus.
Okay, let me try to stop sharing and I share again, maybe to help Daniela. Okay. Daniela, is it visible now?
Teacher, it's visible.
Okay, can I hear from the person who was contributing as Daniela confirms?
I'll say what Primrose is saying is
yes.
Hello.
Yes.
100n plus 2.
100n plus 2. Let us, when you put 1, you'll have 100 times 1, which is 100 plus 2. That's okay. When you put 2, you'll get 100 times 2, which is 200 plus 2. Okay. Joseph, I guess we are having two operations. The first operation is multiplying by 100 and by 100, and then we added 2. Okay?
Yes.
That is the double operation we are having. Eh?
Yes.
What the double machine is doing. So I would expect students to, you can easily tell that the difference between the output was 100. Eh? Okay? But if you put in the counting numbers, for you to reach at what you're having, you have to get the difference times n, where n is the counting number, then you added 2. Joseph, I'm seeing 31 hands up. I don't know. I think there must be.
They are reducing to 11, but we can have Gladys to say something. Gladys, what do you have to say?
Teacher, I don't understand here where you said 100 and
okay, Gladys. Let's see that the difference here. We are adding 100. Eh?
To and subtract 1. So where did you get from?
Sorry?
Our network not.
Okay, I think I've tried to get her question. Eh? Okay, Gladys. If I substitute the first value of the first value of n was 1, eh? Okay, so I'm getting 100 times 1. Okay, but this gives me 100. Eh? And you realize that the output is 102. So for you to go to the output, you have to add a 2, which takes you to 102. Now, when you substitute n equal to 2, that's the next counting number. You're having 100 times 2. Okay? Then this is 200, but the output is 202. So you'll have to get 200 plus 2, which gives you 202. when you substitute n equal to 3, okay, you have 100 times 3, okay, plus 2, it takes you to 300, and so you continue like this, meaning that generally for you to, the general formula you need is 100 times n, where n can take on any number, and then you add a 2. That's why you are having in the expression, I mean in the machine, that's why I'm having 100.
Mr. Theo? Mr. Theo? Okay. I think we have lost him, but let me hope the goddess, I think, is now okay with that. I don't know whether you have any other concern about question 5. I wanted us to move on very fast, given the time we have. I don't know, maybe Anita, let's first hear your concern first.
Teacher, I'm sorry, I forgot to lower my hand.
Okay.
Chirabo's hand seems to be up for a long time. Can you please give her a chance to talk?
Okay, Hannah. Is that Hannah?
No, Hope, Chirabo, Eunice.
Okay. Hope.
Yes.
Yes, please. Please go on.
Yes, my inquiry is on another question. Question 3. No, question 1, another exercise after this one. Like they gave us 3, 5, 7, 9, and 11, and they told us to find the nth term. But when you come to realize the pattern is different, how do we answer that question?
Different how?
No, not this one. I meant this one. That same exercise, but part 3, where they gave us 0, 3, 8, 15, and 24. Yeah, that one.
That is page
84, the last one.
Okay, and that is part A, right?
Yes. How do you answer such a question like that? Because it gives it gives a different pattern. Like each number has its own way it's formed.
Okay. That number, though you have skipped some parts, which is very vital, but if you look at that question, they're saying the formula for the nth term for this sequence is n power 2 or n squared. Okay. So when you look at the sequence, which is there as a 1, 4, a 9, 16, and 25, that was obtained by squaring counting numbers. Remember counting numbers? You're having 1, you have 2, 3, 4, okay, and so on. 5, okay. So when you square a 1, you get 1. When you square a 2, you get 4. When you square 3, you get 9. When you square 4, you get 16. When you square 5, you get 25. Okay. Now you already in the formula for that sequence as n squared. Okay. Now they're asking you, given that formula, which is n squared, how can you obtain now these sequences given from part A to D? Okay. But when you look at part A, okay, compare part A with that sequence, which is 1, 4, 9, 16, 25. You'll find out that they were subtracting 1 from each term. Okay. So like to have, if for part A you're having 0, you're having 3, 8, 15, 24. It's like subtracting 1 from the other sequence which is given, okay? For each term, right? So but you know the formula for the other sequence, which is n squared.
Yeah.
Okay. So to get the general formula for that, it's like having n squared minus 1. Okay. Because now that will be the general formula for that whole sequence, that if you know n squared, which is squaring the counting numbers, then subtract 1 from each term, you'll have the sequence in part A. I don't know whether that is okay with you.
Yeah, but they say that what is the formula for the nth term? Is that the same as n squared? Because meaning that they've just
Yes.
given us the answers in verse
Yes.
one.
When they ask you for nth term, that n is a position of any counting number, any, because it is a variable now. Okay, the n can vary, can be any term. Okay.
Yes.
If they now ask you for the 10th term, where you're having n substitute for a 10. Okay.
Yes.
And then you find the 10th term. So that n is a variable. So what they want you to obtain is a formula with n inside it.
Oh, so then how do you answer part B?
I will request some other girl to try out that, because now you know the crew, you have the sequence that you use. So I request someone to obtain for us part B very fast. Appeal Grace, do you have something to say?
No, we left our hand up.
Okay, guys, if you don't have anything to say, I request you to lower your hand such that we reduce on the quorum of.
But I've understood, thank you. Wonderful.
Okay, but I request someone to do for us part B very fast. Vanessa, are you ready?
Part D or part B? Teacher, for part D, I think it's n to power 3 because it's 1, 8, 27, 64, and like that, I think. And teacher,
okay.
I also had another question of number 5, like the previous question on part B, because like the outcome is 2, 5, 8, 11, and 14. So would the formula be, I worked it out and I saw that we were adding odd numbers. So would the formula be adding odd numbers?
Mm-hmm. That is okay, guys. I think because question 5, which is on page 83, is an exercise for you to try out. Now, since you have the knowledge now already, I request you to try out other questions. Remember, this is your exercise for you to try out. Do it as you summarize your work to make notes. And I think for now, let's first finish up the other question, which is 3, before we head or we move to any other part. Someone was giving us, that is page 84. Someone was giving us part D. They had said B.
Yeah, I've kind of gotten part B.
And that is?
It is n squared plus 9.
N squared plus 9.
Yes.
Okay, very good. Are the girls okay with that answer? That is question 3, part B on page 84. And she's saying, Hope is saying that the formula is n squared plus 9. Let's hear from Yvonne. Are you okay with that?
Sure, I am, but I also had a question of my own.
Okay, but let's first finish up this, unless you have for the other part. Do you have any other question from this?
Yes, it's about this number machine.
Okay, go ahead.
Like there was a question you were explaining that has a sequence of 5, 9, 13, 17, and 21. And you say that the formula is 4n plus 1.
Yes, please.
But then there's someone who asked a question if you're always going to add 1. And I thought like sometimes we are subtracting, but like this, I don't see where you can know that here I am supposed to subtract. Like, is there something you can look at the pictures and you're like, when you're working out, you can be like, I'm supposed to subtract or something like that?
Okay, I have gotten your question, though the last word they are not gotten very well. Now, girls, what you should take for importance, especially when you want to generate any formula for the sequence, is summarized for subtopic 6.4. Okay, 6.4. If you go to that is on page 83. They gave an example. They gave an example of a sequence of 3, 7, 11, and 15. Okay, so if you're given any sequence, now for your level, you'll be given a sequence with, if they want you to find a formula, basically with the difference. Okay, what you should identify is what we call the first term. And the first term is that term in position 1 for any sequence. And when you look at that example on page 83, we have a 3 in the first position. Okay. Now, if they want you to identify the formula, you can first subtract the 2 consecutive terms for that sequence. Say if you get a 7 minus a 3, getting a 4, is it consistent if you have 11 minus 7? If yes, then the 4 you have obtained is what we call the difference or common difference. Why common? Because it is consistent for all the 2 pairs of terms, consecutive pairs of terms in that sequence. So that common term, we identify it as a D, okay? So if they ask you to obtain any nth term, okay? Remember we said n is a position or numbers in the numbers of counting numbers or a sequence of counting numbers. So if they ask you to obtain the nth term, what you do, get that n minus 1, okay? If say they ask you for the 10th term, you get 10 minus 1 to get 9, okay? Now get that 9, multiply it times the difference you got. Remember when I talked about the common difference, when you subtract the 2 consecutive terms, if it is common for all the sequences, that will be the common term. So get the 9 times a common term or difference, sorry, a common difference, then plus the first term in that sequence. And for that case, it is a 3. So that will give you a 3 plus 9 times a 4. So the term that you will get will be the 10th term in that sequence. Now, when they ask you for the formula, you just need to remove now the 10 and substitute it for n, so that you have 3 plus n minus 1. Remember, we are talking about 10th term, but we multiplied 9 times 4. So a 9 is the same as getting 10 minus 1. Then multiply times the difference, which is the common difference, to give you a 4. So you'll be having 3 plus, in brackets, n minus 1 times 4. Now, you can expand that, and the simplification for that formula will give you the general formula for that sequence. Like if we expand this, we shall be having 3 plus 4n minus 4, okay? And when you correct like terms, you'll be having 4n plus 3 minus 4. but this will give us 4n minus 1. Okay, so that formula you have obtained as 4n minus 1 is the general formula for that sequence, which is 3, 7, 11, 15. Now, if you substitute in any value of the counting number, say a 1, okay, for n, when you substitute a 1 for n, it will be 4 times 1 minus 1. But remember, 1 is the position, the first position in that sequence. But that will give us a 4 minus 1, which is a 3. And you identify clearly that a 3 is the term you have for the first, in the first position for that sequence. Even when you wanted the fourth term, which is 15 now, looking at that sequence, it will be substituting a 4 for n, so that you have 4 times n minus 1 to have 16 minus 1 to give us 15. Okay. So generally, what you need to identify for all those sequences where the difference is the same, look out for the first term, meaning the term in the first position for that. Then look out for the common difference by subtracting 2 consecutive terms. Okay. Then get n minus 1 times that common difference, then plus the first term. If you expand and simplify that, you will have the general formula for that sequence. Hope I'm okay. We have only a minute to close this, and I don't know whether we have any other burning questions that we can go through before we end this.
I think we should take these hands before we close.
Okay, we can have Kwagala first.
Teacher, I was wondering, in like a sequence, let's say 2, 4, 6, 8, 10. It's backwards. Let's say 8, 6, 4, 2, and then you keep subtracting 2, right? So
yes.
Why is a difference? Would you say that difference is 2 or negative 2?
Now it will be negative 2. Okay. Where you're having now your D, which is a difference, you put negative 2. So you'll be having 8, now is your first term. Then plus negative 2 in brackets, n minus 1. Okay. Then expand that to have 8 minus 2n. Negative 2 times negative 1 will give us a 2. Okay. When you add 2 plus 8, it will give you 10 minus 2n. So that will be now your general formula. If you want to try, substitute for a 1. Substitute for a 1 where you're having n, you'll be having 10 minus 2, giving you 8, where 8 is the first term in that case.
Okay, thank you, teacher.
Welcome, please. We can have someone else. You can have Anna. Anna, you have
teacher,
any questions before we?
Why is it why do we always subtract 1 from n? I didn't understand that part.
Okay. We subtract a 1 from n because now remember they're asking you for the nth term. Okay, but you already have the first term which you're going to add on to the other product. Okay, so because you're having the first term which you're going to add on to the product you're having that case, it will cater for the one which will be added on to n plus 1 to have a full sequence of n terms. I don't know whether I make sense. Is that okay? I don't know. Okay, maybe let me repeat for the last time. I remember I said that you multiply the difference by n minus 1. and she was asking, why is it that we subtract 0 for 1? And my explanation was that 1 is to cater for the first term, which you're already going to add onto that product. Okay. So the first term is in the first position. Okay. So when you add 1 plus n minus 1, you will have just n, meaning that your sequence will be with n terms in that case. I hope now it is okay. Okay, we already passed time by 3, but we have a number of hands up. But I think Anna is okay right now. Our default, do you have anything to say?
Yes, teacher. I wanted to know if it's possible for a sequence to have 2 numbers, like 18, then 18 again.
Okay, I understand you're looking at the other question. Yes, now that's why they didn't ask you for the formula for that, because now they just wanted you to obtain the next 3 terms in that sequence. So we formulated that.
But you can't obtain that.
Pardon?
Yes, teacher.
Okay, we had a sequence of 18, then 9, we had 3 over 4, okay? So
yes,
if you look at that, it's like you are having each previous term being divided by the next counting number. So for example, the first term was 18. 18 divided by 1, you get 18, which is now the one you have in the second position. Now get 18 divided by 2, you will have 9. 9 divided by 3, you get 3. 3 divided by 4, you get 3 out of 4. Then you have to divide that 3 out of 4 by 5 to have 3 out of 4 times 5, which would give you, that is 3 out of 20, to give you, okay. Then the other one would be, the next one would be 3 out of 20 times 6 to give you a 3 out of 120.
I understand.
Okay, very good.
Thank you so much.
Welcome, please. Any other? Okay, let's use 4 minutes to have this closed. We can have Purity first. Purity,
Can you on the phone? Excuse me, teacher.
Yes, please.
I was asking on the formula for finding the nth term. Can you say a into n minus a plus open brackets n minus 1 into d, whereby a stands for the first term of the sequence, then d stands for the difference.
It's okay, Purity. That's very good. Okay. So if you use variables where your a is the first term and your d is the difference, you can use that as the formula. It will simplify your work. So if you're given the sequence, if you know that as a plus n minus 1, close the brackets d, as your general formula, you just need to identify the first term and then the difference, and you substitute. Thank you.
Joseph.
Michelle?
Joseph.
Yes, please.
As we attend to the questions, can you please end the recording so that the video is not big? Then we can attempt to answer their questions.
Okay.
Okay.